we are looking at simplifying radicals. And the reason why I was showing you the way that I did was because of problems like this and the other ones that are coming. So your first example is the negative cubed root of negative 216. Okay? Now, this is my approach. Prime factorizations, you're thinking 2, 3, 5, 7, 11, 13, so on and so forth. Chances are, all you're going to need to really worry about are these first three numbers. So if I looked at 216 and I try to break it up, I would have 2 and 108. Okay? Notice that I divided by this first choice. So keep going. 2 and 54. 2 and 27. Because 27 cannot be divided by 2, I'm going to move on to the next one. And I will have 3 and 9 and 3 and 3. My goal was to get prime numbers at the very ends of these trees that are on this list. So 216 is the same as saying 2 times 2 times 2, and then 3 times 3 times 3. It is a negative 1. It is a negative cubed root. Whether you want to see this square root or cube root as a house, like the roof of a house, that's fine. Whether you want to see it as an ender portal, is that what they are? With Minecraft, however you want to see it, just understand you can only come out of the house, if you will, in groups of 3. Right here, what I just highlighted is 2 cubed. It's 8. And can I cube root this? Yeah, it will come out as a group of 3. It'll come out called the family 2. Okay, so this comes out as a 2. What will this come out as? As a 3. And we're going to multiply these as they come out. I still have this negative right here. And the only thing that remains right now is this negative 1. Can that come out?
Yes.
That's what? Not I. Negative 1 is I squared. Okay? So that's saying the square root of negative 1 is I. This is not the same thing because the square root, what's this number right here? 2. This is 3. Now this is what this means. Right here that I highlighted in green, it means the following. What number, because this is a 3, times itself 3 times would actually get me that negative 1? Negative 1. So this will become, and it'll come out as a negative 1. I still have the 3, I still have the 2, and I still have this negative. Multiply all that. What do I have? 6. All you're doing is factoring. All you're doing is multiplying. All you're doing is grouping what is that nth root. Let's look at another one. Okay, so your second example in your paper notes, and if you fall behind, please just watch the video later. Our second example is negative 1 over 729.
This is called simplifying radicals.
Simplifying radicals still, yeah. In your notes, I want you to put like an asterisk. And one of the rules, and you can put rule if you want, is that when you have something like the square root of, the square root of a fraction, let's say m over n, could be something over something else. it's equivalent as if you were to break it up. Okay? The same rule applies if I multiply. The square root of m times n is the same as the square root of m times the square root of n. Those are rules. Let me ask you this. Do you think that this equals that? It won't. This is different. So in your notes, I want you to still write it out and put a huge does not equal, because a lot of people miss it on the quiz. They miss it on SATs, ACTs, because they forget the rule. For 500 bonus points, can someone tell me why we've done something similar to this, why this is not equal? Sammy. Okay, so it has to do with if it's one term. Over here, those were one terms because they were glued together with what? With multiplication. Where this is addition, you can't do that rule. Okay, she's right, but she has to finish it out. She's got 250 right now. What have we done, Sammy, that is very similar to this in the past 2 units that you're going to be tested on next class? What have we done that is related to that? And if you can't get no worries, someone else can get the 250.
Is it the combining like terms?
Elaborate.
Like you can't separate a term if it's, or a term is one term unless there's addition signs.
That's what she was saying. It's one term unless there's addition.
So for like gluing terms together, you can't combine them unless you're multiplying them.
Okay, you're almost there, but give me an example. What have we done that you can give me an example? Anyone out there?
Maybe like exponents.
It is something to do with exponents. So it's this right here. Let me show you because I don't want to waste too much time. No worries. This right here is very similar to something that we've done. A plus B squared. Write this in your notes, please. Is not equal to, guess what?
M squared plus.
A squared plus B squared. Guys, those are not equal. Because A plus B quantity squared is actually this written out twice, a multiplicity. You're about to be tested on this. That a perfect square trinomial would be A squared plus 2AB FOILed out. The same way this wasn't allowed as far as in the unit that we just finished, Unit 5, that's the same way this is not allowed. Okay, and it has to do with one term versus 2 terms versus multiplicities, and then those are your examples. Okay. So now, I'm going to use one of these rules to break this up. And I have cube root of negative 1 over the cubed root of 729. Okay? Yep, I use this rule right here. Do you know the numerator? What's the answer to the numerator? Negative 1, nice. Some of you know it, no worries. If you don't, you should start with prime numbers and see, can I divide 729 by 2? No. Can you divide it by 3? You can't. Okay? For the sake of time, actually, no, I'll just do it. 729 would be 3, and then 2, 4, 3. Remember, guys, we couldn't divide this one by 2. divide that by 2? No, none of them will be able to be divided by 2. So we should try what again? 3. So we have what? 81. Some of you can already see this. The 81 will break up to what? 9 and 9. And look at this. You already have 9. So you have 9, 9, and 9. That's the same as writing the cubed root of that. Will these 9s be able to come out of the house? Why? Because it's a group of 3. And when they come out, they're going to come out as what? As 9. So your answer? Negative 1 9. Questions? So far so good, right? Pretty easy.
What happened with the fifth? Why is it?
Because these 2 3s were 9. So I had 3 9s. So how you group stuff, how you piece it together will help as far as what numbers am I looking to pull out. Okay? They do get more involved. Let's go ahead and begin. So negative 125. So we have x cubed z to the 15th negative 125. And we're going to cube root this thing. Okay? Again, I'm thinking about my prime numbers, factorization-wise. And I'm looking at 125. That's a z. So guys, 2's look like this. Z's, I'm going to put a slash through it so that you know that that is not a 2, and it's a z. And I ask that you do the same, please, so I can read your work better. Put z's with the little thing, little hash through it. All right. Can I divide 125 by the first prime number of 2? No. Can't. What's the first prime that I'm going to be able to divide 125 by? 5. So it's 5 times 25. This will split up to 5 and 5. So this is negative 1 times 5 times 5. So 3 5s. How many x's do you see? 3 x's. If that helps you, write them out. But I'm not about to write out 15 z's. I think you'll get the pattern already. Okay, so let's look at our negative 1. Guys, does the negative 1 come out? Yes, as what? As negative 1, because it is cubed root, not square root. Okay? Do these 5s come out? As what? 5. Remember, you're going to multiply them. You're going to combine them all to one term through multiplication. Do the x's come out? Yes, as just one x. Okay? How many groups of 3? 5. 5 groups of 3 will come out. So it'll be z to the 5th. Guys, did everything come out? Yeah. And technically, 1 is left underneath the house. But it's okay because the cube root of positive 1 is still 1. So multiply all this together and we get negative 5x z to the 5th. Please write the z's the way I do, okay? Again, because I want to make sure that I understand the difference between your 2's and z's. Alright, now that you know what to do, I'm going to start speeding up the process a little bit to get to the answers. Let me know if you are struggling. Ask questions. So m to the 6th, n to the 11th, and we're going to take the cubed root of 135. I'm not going to write them down, but what's the prime number that I'm going to start trying to break up 135 by? 5. 27. The 27 I can break up. 9 and 3. This 9 I can break up. 3 and 3. So my prime factorization pieces yielded 3 of these 3's and 5. Remember, you know where to stop. You can't branch out anymore when you reach a prime number. So, coded, if you will, that is 135. 3 times 3 times 3 times 5. Huh?
How do you know if you don't put the negative one? Like in all the other problems that started with a negative.
Because that's not the problem I gave you. If it gave you a negative, then that's what you do. But this does not have a negative in there. So now, we're going to take the cube root. I'm not going to write these out. What comes out? The 3. How many m's come out? 2. So m squared. How many n's come out? 3. How many stayed in? How many n's remained underneath the house? 2. Did anything else remain underneath the house? The 5. There's your answer. Simplifying radicals. I hope my pictures of drawing these out, whether they're m's, whether they're n's, groups of 3, help you identify what it comes out as. Okay, let's keep going. Our next example is 96 c to the 10th, d to the 11th, and e to the 6th. And we're going to take the 5th root of all of this. So now the gateway, the gatekeeper, if you will only let them out if they're in groups of 5. Let's break 96 up. What's the first number I'm going to try? 2. And what is it? 48. 2, 24. 2, 12. 2, 6. 2, 3. I know to stop at those ends because these numbers are prime. So I have 1, 2, 3, 4, 5 2's, and you could have done it like this if you wanted. You could have done 5 2's and 1 3. Instead of writing them all out. And you could have seen right here, this is going to come out as a what? 2. Just a 2 all by itself. Does the 3 come out? No, that stays in. Do the C's come out?
Yes.
How many? 2. Do the D's come out? How many? 2. How many are left inside? 1. Do the E's come out? How many? 1. How many are left inside? 1. Guys, if you have to write 5 2's to see that it comes out as a 2, by all means do it, please. Otherwise, all of this is your simplified answer. Easy? Okay? Let's step it up a little bit. Don't freak out, just a little bit more involved. We're going to take the square root of the cubed root, 64x to the 12th, y to the 6th. All this is, guys, is just 2 problems. That's it. Let's do what's inside first, almost like parentheses.
Wait, so what did you call it? It's the, what to the cube?
So it's the square root of the cubed root of 64x to the 12th, y to the 6th. Okay, ready? Let's concentrate just on the blue stuff. Okay? I can start with 2's, right? Now look. The reason why I was showing you this is because I can take 64 and I can try dividing by 4. 4 times 4 is 16. Times 4 more is 64. So this right here is actually 4 times 4 times 4. That's what 64 is equivalent to. Because this is a 3, what will come out? 4. Okay? How many x's will come out? 3. How many y's will come out? 2. What's left underneath the square root, the blue one?
Wouldn't it be 4 x's?
Oh,
I said 3, but it's 4.
it's 4. Yeah, okay. Nice catch. So yes, there are 4 x's and 2 y's. Nice job. Nothing is left inside. So we're just going to take all this off because only 1's left inside. And really all we're needing to do this time is take the square root of what you have. What will the 4 come out as? 2. How many x's come out? 2. How many y's? Just 1. There's your final answer.
So I got the same answer, but what I did is I multiplied, because you put the problem as the root 2 and then underneath root 3. I multiplied that, so I put the whole thing as root 6, and I got the same answer.
Okay, so, yeah, so look, check this out. The square root of x, please write this in your notes, thank you Anika, is the same as x to the 1/2. The cube root of x is the same as x to the 1/3. Let's say that I had something like the 5th root of x cubed. That would be written as x to the 3/5. Okay? And what Anika said just now is very, very important, because here's the thing, guys. What you will learn in this unit is that it's similar to the last couple of units. You don't have to do things the same way that someone else will do it. Someone else might do it faster. It depends on their strengths in math. Okay? 64x to the 12th, y to the 6th is all raised to the power of 1/3. And then it's raised to the power of 1/2. We've learned recently, and you will be tested next class, a power raised to a power, what do? You multiply. So what this is really looking for is the 6th root of this. And you could do to the power of 1/6, or you could write the 6th root like this. Okay? What times itself 6 different times would give you 64? 2. So that comes out as a 2. How many x's come out? 2, because it's groups of 6. And then how many y's? 1. You're exact. Oops. I need to put 2 instead of 6. So yes, this is much more efficient.
That one is?
Yeah, if you're understanding how you can manipulate stuff. And I ask that you just do with whatever makes you feel comfortable. Ultimately, it'd be nice if it was to this level. Okay? Now, there's some more stuff involved. Let's look at root 15, 5 root 20. Many things, many different ways you could do this. So I see 15 as 3 and 5. I also see 20 as 4 and 5. And now I can start trying to see, can I cancel forms of 1? Look at this. The top, because of a new rule we recently learned, looks like that. The bottom, because of a new rule we recently learned, looks like this. And I can cancel these because it's between multiplication and they have the same power. 1/2. So that's a cancellation form of 1. Can I cancel anything else? Nope. So I'm left with root 3 over 5 root 4, but I have to do something called rationalize. Write this in your notes, please. Rationalize the denominator. Get rid of that square root. Square roots are not allowed in the denominators. Okay? How do I get rid of it? By multiplying by what I see. But I can only do this. This is not an equation. There's not what you do to one side, you do to the other, because there's no equal sign. So manipulation here is only legal mathematically if we multiply by a form of 1. Well, let's get there real quick. I have this root 4, come on, and this root 4. Can someone tell me what that would equal? 4. If you don't see it, it's the same as this, which is the same as this. How many of these do I have? I have 2. My hope is that you understand it to this level. What happens between this squared piece and that? They cancel. What's left? What's underneath is left? 4. Okay? Now, I did all that because now in the denominator, I'm just going to have 4 times 5.
Yeah, but isn't there, why wouldn't it be 2 times 5?
Because root 4 times root 4 is the same as,
But there's only 1 root 4.
there's 2 right here.
Yeah, why aren't we looking at the top? What if we start?
We're not looking at the top here. We're just concentrating on the bottom right now. Okay? And this would become 4. 4 times 5 would give you 20. Now let's look at the top. What's root 3 times root 4? It's the same as this. Right? From a rule that we learned that you put an asterisk by. So this 4 can now come out as a 2, so that your answer would be 2 root 3 over 20, but it's not simplified fully because I could reduce 2 and 20. This would be the answer. You will have to go back and watch the video, possibly. No worries. But I want to make sure that we have a couple more example problems shown. Let me show one more. Root 2, okay, over 2 root 3. And if you have to go back, please go back and watch just the end of it. This is another example. We have to rationalize this denominator. So I'm going to multiply by a form of 1. What is it? Root 3 over root 3. Because now these will become what? 3. What will the top become? Root 6. Can anything come out from that? Nope. There's not a pair. And the bottom would be 6. Much easier, right? Alright, I will record a couple more examples during 8th period because I don't have the time to do it. And I will add it to the end so that there'll be a part 3 for today's notes. Please make sure you have that homework not ready for me next time because you're testing, but the day after that.